Hey, good morning, friends. This is yet another session from us. This is hacks on Java. So we will be using some tips on how to improve your performance, how to code faster, how to code better. All these things will be covered in this. It will be in lot of topics from beginner to advanced users can actually make use of this. Very good for programming. From the programming perspective, this is very good. We are not covering each and everything about programming, but it is generally uh, accepted solutions to increase the performance and how to make a good Java programming. We discuss that uh, more. Okay. Yeah. So please keep watching. This will be uh, very beneficial for everyone. I hope that. And please like, share, subscribe, and comment. That's how all the YouTube channels survive and succeed. So thanks for your comments, views, everything. If you have any doubt on this, please ask. Okay, it's just comment on that or ask. Okay, we'll be happy to help. Even in the case of projects. Yeah. So let's start. Today, as I told you, this is the session about Java. We had a lot of sessions of Java. This is another one. And here what we discuss is how to improve the performance. This is actually very small points because the first session will be for beginners, then for the intermediate, then for like that we have made. So hope you all enjoy it. So this is one, because when we use the array length, it actually goes and fetch it every time. So instead of that, if you store that, then we actually don't have to fetch it every time. That is what we are given here. So we actually stored it in an array here. I mean array length L variable. And instead of fetching it every time, we are just okay. The next one is so you understand, I think. The first thing is here we can see we are in this for loop, we are using array dot length. This here we are using L. Okay. Yeah, this we are assign the array dot length to L and we are using it here. Next is actually string catenation. String catenation is also something what you saw like something what you saw earlier. So instead of using string catenation here you can see we are actually directly using in catenation inside result. Inside the for loop, instead of that result plus equal to str. Result is a string and we are adding str to uh, result. So that's a bad practice and you should use string buffer. It is coming below. Right. Every time we are actually adding. So this is not good. And this is the recommended way. A string builder is the recommended way for adding inside. If you want to add lot inside a loop, you can use string builder dot append. Okay, that's it. Okay, next is So that is you can see hello world, how are you, like that. That is coming from the result. Okay, after going through appending after appending the result and assigning the toString is yeah. So let's go forward. So in the inside again, optimizing map initialization, instead of giving default map length, we should always give no map length. We should actually every time, what happens is every time we give if we don't give a map size, it tends to increase the size every time. So instead of that, we can give a default size what we are expecting, and initial capacity has to be given. So that's what. So in first we didn't give any initial capacity or the size, expected size. So next what we give is we actually create another object. Here, see, capacity we give as 100. Okay, earlier it was 0, now it is 100. Okay, this file actually doesn't exist. Actually, we should actually always use exceptions, try catch exceptions, and log it if there is any exception. But here, this particular file now, file.txt actually doesn't exist, so it will always throw some error. So buffer the first time itself, whenever we are trying to use the reader, it will throw an exception, but we are not handling the exception here. You can handle it in any way. Okay, so you can log it or do something for the to overcome the exception. So instead of we actually skipped on point, I think. Okay, enumeration for constants, we can give enumeration. That's a very nice elegant way of putting constants. Okay, in enum, give enum values like this. Next is the functional interface. Actually, we will go through functional interface and lambda expressions and in another part also. But for now, we are actually giving for each system.out.println, which will actually you may note that the numbers is a list. Inside that we are using for each. This one actually is giving much better performance than others. We are not actually using println every time, but instead we are directly using for each, and from that calling the println. Next is the parallel stream. Actually, okay, when using parallel stream, what happens is the order of this array actually changes. Actually, order of this list actually changes. It will not be printed like this. It will be printing some other way, a jumbled way. It will be different way, but it increases the performance. Okay, if you have a very large list or very large array, okay, you can use parallel stream. Just because multiple threads are involved, the printing will not be in the correct order. Executor service, this is actually multi-threading executor. So we are using this executor service for that, to manage the number of the threads. We are launching a worker thread and executing it. Worker thread is actually a runnable normal object with a runnable interface, actually implementing a runnable interface, and this execute method actually calls that run method. And once it is done, actually we'll have multiple threads like this. We have 10 threads. Every time it creates a runnable object, worker thread. Here it creates a worker thread. Only like that it continues create, and then the service is shut down. I see. While not when all the threads are done with this, has done the execution, or everything has exited, this particular message will be printed. Execute service is terminated. All the threads have been terminated. It checks. Okay. Please understand this. This is actually asking if there is any more threads left. Wait, that's what it says. You can do other type of waits also, but here we are doing just an example. Okay. Next is the worker thread. Okay, we are discussing about the worker thread earlier. So this is the worker thread class. Worker thread actually implements a runnable interface. See this, just say the thread is running. That's all. Inside that, whichever thread is running, your task or thread is running. Here, I hope you remember that we are giving task plus I. The I is actually value to indicate which is the thread sequence. This also, because it is multi-threading, the order will be different, printed differently while running. This is how we invoke new executor service example.esc. Again, sorting objects with comparable interface. Everything, all these things actually improve the performance when using multi-threading. Using this one also. Actually, we are using comparable interface here. Employee is we are just having employee name and age. I think age and number or age. Okay, age. Okay, employee implements comparable employee. This is what we have done here. So this is the syntax. Employee class employee. We given this class. This is the class. It implements a comparable interface with of type employee. Okay. So it is all normal. Employee name, integer, age, everything is normal. Get name, get age is there to retrieve things. And normally compare to should have an equal also. Okay, so when you are doing real programming, make sure you have equal method as well. So compare to employee MB, this is how it is compare to this dot name, and compare to employee emb dot name. So this method will be giving an integer value, and in running this, actually we are creating a test here. You can even either create a test class or you can use like this, no issues. We create employees and add them to the list. Then we sort it. This is what we are actually interested in. Okay, because we gave the comparable interface and then we sort it, and here when we print, we get all the everything in order. This one we can give something else as well. Okay. When we are debugging, I mean adding all the values. Now actually all the values will be inside this EMPS list, and from that size is 3. You can see we are going and printing. Here see, now we came out of the loop and coming out of the class. This is how where everything starts. Okay, from there C method is called, and from there everything, the loop and everything gets executed. So in this, what actually from here now, custom exception example, we are showing custom exceptions. Yeah, so here also, because it is throwing exception, we have to what is happening. I missed out some. Yeah, custom exceptions. I think I pressed the wrong key. and we are throwing actually the new custom exception. If we created a custom exception, and inside this my custom exception is being thrown when number is less than 100. Okay, this next one, that is using reflections to invoke a method. We are using the reflections API to invoke a method. If you have, this is a very good way of doing things. I mean, if you have a very what is that, a trademark oriented application, it is best way to use. I created my class object here. Let's see my class doesn't have anything other than name, I think. Okay, my class I created, then just print name is there, other. Okay, then I create a object, class object. I give inside my object, I create my, from my object I got my class, I created my object, I got the class name here, and from that I am getting the method name. Okay, example print get method print name. When directly use it, but this is actually the in certain situations this is required. I mean, it is up to your project manager or your higher authorities to decide. In normal case, you use it or not. In some cases, this is required. This is a must. In some other cases, it depends on the other team, business team or architect. Okay. If you certain things that you should have known between, yeah, reflection sample is there. So we are actually invoking my object. This is the method name. Okay. Print method dot invoke my object. Print name object. See, this is method. My object is this one. So you created my object, and print method from using this print method is actually the method of my object itself. Print name, that is the method name. So using this method, we are invoking the object. That means this particular method will be invoked. The print name will be invoked. Again, coming down, yeah, singleton. Singleton object actually inside one instance there is only one. It's one JVM. If we are running, this is for a particular application. This is the only single class available or object available. You will not have multiple objects. So in order to achieve that, we have used the singleton method and other things. This is a very simple one. So inside this, that's an empty constructor private. Since this is a private constructor, you should actually say this singleton class singleton is there. This is a private constructor singleton. Since we are using private constructor, it cannot be called at any point. Okay, there's no other constructors here, and we are actually creating a get instance method, a static get instance method that returns a singleton. So whenever we want to create this object, we have to use singleton, that is a get instance method. If instance is equal to null, what happens is it creates This is thread safety. For thread safety only they have given synchronized singleton dot class. Okay. Then if instance equal to null, a new singleton is created. Singleton object, that is instance, is created. This is a private, as you know, this is a private. This can be called from only within the class. Constructor can be called only within the class, cannot be called from outside. That actually rules out the possibility of creating multiple instances. And actually, whatever case, if instance equal to null, then this particular loop is invalid. If it is null or not, actually we have to return the instance. So that is why we are returning the instance. Anyhow, this actually makes sure that only one instance will be inside or inside an application instance. So again, it is immutable. This actually singleton, immutable are all going in the parallel. I mean, it is very similar. Immutable program, immutable person is actually a immutable class. Immutable class is you can't change values of class once it is created. As you can see, it is private string, private final. Okay, final is a constant, and is same as private final age, string and integer age. In a string name and integer age, both are private final. So you can't. It means it is a constant. You have to, if you want to change, you have to change it through the constructor only. So here we add everything to the constructor. We have age and name returned. Getter methods are there. This is the immutable class. So it is a finite class. You just remember this one, finite class. Then this is all the member variables or member data members are all private final. Anything have to be changed, you have to change it through the constructor only. Constructor is public. In the earlier one, singleton, constructor is private. Everything is got through the okay. You get the data once it is set through constructor and get the data through the getter methods. Okay, again the immutable person is actually similar to this employee. I mean, it is a record employee. You don't have to do anything. If you want to call, if you want to make object, you can make it. This actually, you may remember, this is the keyword. Record is the keyword, and to create an employee, you have to give the ID. It's the same as any class now creation, but only thing is that you cannot, once it is created, you cannot change anything. But there are ways to change something. Actually, you can call it immutable classes are actually constants, but in this case, what happens is you are able to change some values, unchangeable value. That is what they call it, unchangeable. Even though they call in some cases they call it as immutable. Mainly we can consider it's unchangeable. Okay. We create an here you can see we create employee like this. It's very simple. I mean, this we don't have to actually the boy just think the we are actually getting rid of all the boilerplate codes, getters, setters, everything is gone away. We don't have to do anything. If you want to create a DTO, you can do this very fast. See, you created that object, record object. Employee is a record object, and you actually see this values in the console. Again, we have a builder design pattern. Builder design pattern actually, when we are actually sending lot of parameters, there's a possibility that you give wrong parameter names or wrong parameters in the wrong places. So in order to avoid that, we have the builder pattern. So with the builder pattern, you can send the builder. We have created a user builder here inside the user class. Whenever you want to send something, we can use the user builder. You can create the user builder, so, or you can directly send it to the user object, and create it. It's very simple. Just go through the code. You can see the code here. Everything is simple code we are using. Only thing, okay, user, as you know, if you are aware of builders, what happens is we'll create a builder. You builder using the constructor. After that, we will use dot and create. After that, here if you think that user builder, we created the user builder. After that, okay, since this is actually returning, constructor actually returns the object, we'll be using dot age, set age. Okay, set age here, and again that one also actually returns what user builder itself. So coming down, you can see that. Okay, then we have the build method. The build method will actually return the user. So when I am actually printing user builder. This it is a static one. Okay, user builder age 49. You can see this. That is create this constructor, then age, then we build it. It will actually return the user object here. That's what happens. Functional interface. Yeah, this is a functional interface example. Okay, so at the first one, we create the functional interface using the functional interface tag, and afterwards, we inside that interface we create a perform operations method in A and B. It is very simple one, and inside the class we create a method. Inside the method we create lambda function, math operation lambda function. It is name is add and subtract. When we get two parameters a b, add will actually add it, and subtract will subtract it. That's what happens. Perform operation will actually return values. Again, another one is that we create a custom annotation. Yeah, here actually we are using this annotation functional interface, and here we are actually using the functional, we are creating a new custom interface, or a custom, sorry, annotation. We're declaring public custom annotation string value. This is the only thing that we have to give. That's it, annotation. But this one, we actually concentrate in these things. If you actually have any, because in the annotation side we don't have to go at this point, we will go, actually annotation is very large one. I mean, we have to go then more deep. Even in this, most of the people may be finding a bit difficult, even though I covered in a very short time. If you have any doubt on that, please ask. Okay, so please continue to share, like, comment, and if you haven't subscribed yet, please subscribe.